Hey everybody, all two of you. Welcome back to Young Engineers of Today. I guess I'd ask you how Hurricane Raleigh is treating you right now, but I imagine by the lower attendance, that many of you are running into the same issues that I was earlier today, which is totally understandable. Did you guys who are here? Did you guys, Isaac and Micaiah, did you guys even have school today, or was it shut down too? Okay, so that makes it a little bit more difficult. It's not like school can exactly be shut down for the day. Oh, yeah, okay, okay. That makes sense then. So both of you are in the same situation. Well, my condolences on not having a day off. But, at least you don't have to make it up during the summer, like everybody else will who has the day off today because of inclement weather, which wasn't even really all that inclement. Well, I say that, and it was absolutely horrible for about 20 minutes, and then it was fine. Thought my windows were going to be ripped out, and then nothing came of it. Um, yeah, see, there you go. You got a good viewpoint about it. You're cool with it. Um, in that case, then today's going to be pretty relaxed because A, we've got two people here, and B, I'm going to be perfectly honest with you. I'm not even feeling terribly well. I've started to come down with something, and so you might hear me, you know, sniffle pitifully a few times throughout here and there. Um, I apologize for not being in top form. I know uh, as a leader and role model and all-around ideal human being, I should never be sick, but sometimes these things happen. Oh, hey, we got a third person. Cool. Welcome, welcome, Hudson. I was just explaining that because of low attendance and because I'm not exactly feeling 100% tip-top. That's right, your Fusion wouldn't open, and the video wasn't up there? Because I definitely uploaded it. Let's just go ahead and check that out right now. Engineers of Today. Because I know I uploaded two videos um, for Monday, but you are right. I'm not seeing this here. Let me see if I accidentally made it private or something. No, no, it didn't get uploaded. That is strange. Something must have happened with the recording because I definitely uploaded it, and I'll re-upload it tonight. I apologize for that. Um, and yeah, once I get it uploaded, I can definitely link it to your email so that you have that. I know, but I made a commitment, dang it. I was going to make sure that these all got uploaded, and this one didn't get uploaded. And then another one didn't even get uploaded because I ran into issues with the recording. I'm already failing on it. I'm already failing on it. No, I'll make sure the video's up tonight. And I'll send you an email with the link. So I'll double check your email at the end of class, make sure I've got it correct, and expect that email tonight. So, might be later tonight because I run on an internet that I'm pretty sure is powered by duct tape and men on horseback, but it'll get there. It'll get there. Men on horseback handing letters to other men on horseback. All right, well, let's go ahead. Are you able to get your Fusion open now then? Did you get that issue all resolved? Okay, well that's good, that's good. Why don't I go ahead and open it now, and we can start some work on that together. There it is. You can see my incredibly well-kept desktop. I assure you, it is exactly as well kept as my desktop is in real life. I am a neat person, I am. So, I know I kind of asked it earlier, but did you guys actually experience the impending doom hurricane that came through? Strong winds. Yeah. Lots of rain and wind. Yeah. And you know what? Don't worry about it. Like I said, we don't have many students right now. I'm going to spend a little bit of time sort of doing a review of what we did last time anyway. Um, and then I'm going to start talking about cam mode and tornadoes. Yeah. So I hear that actually happened about northeast of Durham. Uh, Durham got some pretty interesting weather. We are 7 p.m. Okay, Fusion is up. I agree. All right, so what we basically did on Monday was we set it up for cam mode. So we had the. What if I can just click on one of these and bring it up? I did all the cutting out real quick because all of my stuff didn't save from last time around. And then we created a stock. And the stock basically represents what we're embedding our bookshelf into, so that when we cut it out on a machine that a man invented or a group of people invented that is computer controlled. I'm telling you, I'm really not feeling 100% right now. Pop quiz, everybody. What's that machine called? Uh, CNC machine. Thank you. Gold star. Yeah, we're working on creating all the slots for the tabs. Well, that's what we did the day before, and then we embedded everything into the stock, and then we laid everything out. And part of that involved creating components. Um, Basically, we turned all of this stuff into components. Really simple process. You just selected everything, right-clicked, and then created the components from create new components or create components from bodies. Yep, it says it right there. I should probably read it. Create components from bodies, and it turned everything into a component. And then we were able to use the joint function under assemble in order to basically make sure that it stayed at the same level as the stock that we created. And the stock was really super easy stuff. It was just a box. Only tabs on the back half finished. Aha. So you've got tabs on the back wall. Do you not have tabs on the side walls then? Because I think that's actually related to the video that had the sound issue as opposed to the most recent one that just had the upload issue. I swear I'm more on top of things normally than this. Just shelves. Okay. So, yeah, you would need to put the tabs into the back and then the tabs onto the side walls. Okay. Tell you what. I'll send you a PDF after class that is everything that we've done so far. So that you can have all that and then go at your own pace. That should be, yeah, and that's the PDF that I work from, and it's full of all kinds of helpful and less helpful notes. Um, but it's just a step-by-step process to get everything done so that, you know, you can be at this point. But that should be everything you need, and then I'll get the YouTube video up tonight as well. So that'll be double whammy. There, I said it. I actually said double whammy, unironically. Okay. Yeah, because we did the tabs on last Wednesday. We got the tabs and everything, and then we cut all of the slots out last Wednesday as well. And just this past Monday was all about getting the everything embedded in the stock. Okay. So yeah, that's where we are. We got everything embedded in the stock, and we downloaded that software, that add-in that allows us to create the dog bone pattern on the tabs. And the reason we're doing that is so that the tabs will, when they slot themselves, when they're not magical, when you slot them into the slots on the other parts. So like when you're putting the shelves into the side walls and the side wall into the top, and vice and whatever. There is more stability in the construction because these sort of flared edges right here ensure that it won't be pulled out so easily, and then having the corners sort of rounded out like this means that it'll be easier to put it in there because of the flared edges. So all in all, you'll have an easier time building it and a more stable construction. And that was an add-in that we downloaded and basically installed, for lack of a better term, into Fusion. And it did all that automatically, because otherwise we'd have to do all that manually. Basically create all of these little rounded parts and everything like that, and it would just be madness. It would be so much work that it wouldn't even be funny. We would spend weeks and weeks and weeks of doing that just over and over and over again, and it'd be really boring and everybody would be bored. So we're trying to avoid that. So that's why we downloaded that. Once that was done, though, that's pretty much where we left off. We have one more thing to do, and then we're ready to go into the next mode. I hope somebody's keeping a running tally of how many times I've said we have one more thing we need to do before we move on to the next thing. Potentially bringing your hopes up for but a moment, thinking that we're done with modeling this. We're never going to be done with modeling this. We're going to keep modeling it forever. It's going to be your entire semester. It's not actually going to be your entire semester. I feel like it's going to be forever. Okay. So, like I said, one more thing we need to do in this mode before we get started in cam mode. So I'm going to hide my stock again so everything's easier to see, because that Z fighting is really annoying. And you see these blind tabs here that we've got in the top part of the bookshelf? We've got like these 6 different slots for the blind tabs. Well, what we're going to do is we're going to actually embed those a little bit deeper into the top. The reason being, right now, assuming pinpoint perfect manufacturing, no issues whatsoever, everything would lie flush. Even with computer-controlled machining, impurities in the material that you're using, general weirdnesses involving physics, like things expanding and contracting because of the fact that that's what they do when the temperature changes, stuff like that, it's going to make things a little wonky. So what we're going to do is we're actually going to give it a little bit more breathing room in here, so that the tabs, like the top tabs on the back and the top tabs on the side, well, we get to meet you in Charlotte. I actually live in, well, Chapel Hill, basically. So I don't actually foresee myself going to Charlotte's anytime in the near future for labs. But, life is crazy. Who knows? I might be down there before the end of the semester. So basically, to answer your question with a non-answer, maybe. Okay, so here's the deal. In order to, yeah, account for those weirdnesses with uh, physical materials and life and things like that, what we're going to do is we're going to go up to modify, and we're going to press pull. I'm going to rotate it upwards so I have a better view. The bottoms of all of these, and I say bottom, it's not actually the bottom because this is the top. We're actually looking at the top of the bottom of the top if we want to be really confusing, and that's always fun. But, you know, for simplicity's sake, these are the bottom bits right here. We're going to start speaking in relative terms as opposed to absolute terms until they decide otherwise. Anyway, I selected all 6 of these slots here, and we're actually going to offset them by a certain amount. Let me go ahead and find it. I believe it's negative 0.04. Yes, it's negative 0.04. So just go ahead under distance, type negative 0.04. Boom. And it's going to go down a little bit, and that will be that. So we've given it just like the tiniest little bit of wiggle room. So like I said, in case, you know, the tabs expand or you know, the material we're using has some sort of weird knot right at one of those tabs and gives us a little bit extra material, or something like the stock moves during the manufacturing process, whatever the case may be. We're going to have a little bit more to work with in those top line tabs. All right. So guess what, you guys? We have built a bookshelf from scratch. We have taken a two-dimensional drawing and we've wiggled it and stretched it and expanded it and added greeblies and mirrored it and done all kinds of stuff so that we had a bookshelf model. And then, not satisfied, we kept doing that and cut out bits and added more bits and did all kinds of wacky stuff so that we had a model of a bookshelf that actually could be constructed in real life. And then, not satisfied with that, we created a box and flattened it and moved stuff around and added all kinds of little doodads so that we created a model of the bookshelf that we could construct flattened out on a piece of stock that we could then cut out with the CNC machine. We are officially, yes, officially done modeling the bookshelf. All of those steps, and now we've got this weird exploded thing that's laid out flat, which, you know, looks kind of unimpressive, maybe, but knowing everything that went into it, it's pretty dang cool. Now, we get to switch modes for the first, the first time ever. Insert dramatic music. So you'll notice in this drop-down menu on the upper left-hand side, just below the data panel where we've loaded our model each and every time, there is this thing that says model, and if you mouse over it, it says change workspace. As you might imagine, what this allows you to do is change your workspace. It's really actually kind of an uneventful reveal. But click on it, you'll get a drop-down menu. You've got model, you've got patch, you've got render, you've got animation, you've got simulation, you've got cam. So, you know, render could be if we wanted to get like a nice fancy 3D render of it that we could then, you know, show to somebody as a really fancy kind of look at the thing that we want to make in order to impress, you know, shareholders or potential customers or whatever. You've got the animation in case you wanted to show off how your bookshelf could walk across the room for some reason, in case you invented that in a bookshelf, I don't know. But anyway, you could do that with animation. More realistically, if you know, made a, I don't know, a two-stroke engine in Autodesk or in Fusion or something like that, you could animate it and show off how that would work and, you know, actually rotate around it and things like that and get different angles. You could simulate it in case you're trying to make something that needs to be able to withstand certain temperatures, or needs to be aerodynamic, or whatever the case may be. You could simulate various things with that. A lot of these involve also plugins as well, so they aren't necessarily going to work straight out of the box. Now the last one is the one we're interested in. That's CAM, which should come as no surprise to anybody, because that's what we were crowing about, or what I was crowing about in the beginning, is that Fusion 360 also has a CAM mode, which allows us to skip additional software, because usually that's a separate set of software. So now we're in CAM mode. Our model looks exactly the same, but a few things have changed. You'll notice over here in the browser, it is a lot leaner than it was before. It doesn't list all of our components and sketches and construction planes and all of the other stuff that we created in order to make this model. All we have is CAM root, we have our bookshelf, we have units, and we have operations. In fact, you might notice something about units that's a little bit wonky. And then we have a different toolbar along the top here. We have setup, 2D, 3D, drilling, tuning, or turning, actions, inspect, manage, add-ins, and select. Well, inspect and add-ins are not really new things. Those were in the model as well. But regardless, most of these are different. Whew, I need to take a breath. It's really hard when you can only breathe out of your mouth. Okay. In that time, you guys might have noticed the wonky thing about units. It's in millimeters. This is kind of the annoying thing about changing workspaces. It doesn't save any of our stuff from before. So the units got reset. If we go up to File up here and take a look at our... sorry, I wasn't there. Anyway, when we go to our user presets, you'll notice that our user presets also aren't there. It doesn't save any of that stuff, and it only applies for the model workspace, which is kind of a bummer, but maybe that will change in the future. For now, though, most of this is going to be an easy fix. Under Units, I'm just going to go ahead and mouse over it. Another little icon pops up to change the active units. We're going to change the active units over to inches. Boom. Done. Easy. Easy peasy. For the presets, we aren't really going to use those as much anymore because most of that stuff was used in the model. There are going to be a few things that we're going to need to use that are going to be in the like we're going to need to use the apply preset and stuff like that, but we'll just enter in those values manually. It won't be that big of a deal. So first things first, CAM works differently from model, as you might expect. Model, generally you start with a sketch, and then you start fiddling with that sketch and adding new sketches until you've got the thing that you want. CAM is all about simulating how the CNC machine is going to move. To that end, the CAM mode works in terms of setups. We have a setup. A setup simulates the machine that we're going to use, the path that the tool is going to take, all of the wiggly computer stuff that it's going to do, and we sort of modify it obliquely with telling it to do, okay, go a little bit slower, or, make more passes, but we're not going to necessarily say, we're not going to be necessarily as specific as we were in the model. You'll see what I mean. I explained that poorly, but it always helps to see how these things work out. So anyway, under Setup, you can just click the drop-down menu and go to New Setup, because that is our first step towards creating the toolpath that the CNC machine is going to use to cut this. You'll notice a few things that pop up when you first click on that. This may or may not already be selected for you. That's largely dependent, as far as I can tell, on luck. For some of you, model might already be pre-filled with the 7 bodies, as you can see, 1, 2, 3, 4, 5, 6, 7, that comprise our bookshelf. Some of you, maybe not. If it's not, no big deal. All you do is you just click on these in order to bring them into the fray, and it will be smart enough to figure out that, hey, this is what, you know, these are the 7 bodies we're going to use to represent the model we're going to be cutting out. Not too bad. Next thing, we've got this work coordinate system here. That's just basically a fancy name for this axis over here. The axis sort of represents that. Basically where the CNC machine is going to start and where it's going to regard like the beginning at. Like, let's say you were drawing, let's do it this way, show of hands. How many of you had those little books when you were a little kid or younger? Maybe not when you were a little kid, but maybe just when you were younger, that had like that grid, and then there was like an elephant, and then the elephant, there was a grid that had an elephant in it, and then there was an empty grid, and then they were like, we'll teach you how to draw this elephant. And the whole idea was you would just draw what was in each individual square, and eventually you draw an entire elephant. Like, let me pull up one of these in order to get a better idea. Now Isaac knows what I'm talking about. Oh, that's the wrong window. Draw grid. Okay, I noticed too. Here we go. Actually, this is a perfect example of what I'm talking about. We'll let it load. But as you can see, like, you've got this grid of a drawing, and then you got an empty grid over here, and the whole idea is like, I want to draw a poo. Stifle your giggles. But with Spider-Man. Yeah, exactly. So you'd start out like maybe you just go like, okay, in this upper corner over here, there's the leaf. So you just kind of be like, nay. And you do it piece by piece. Anyway, you get the idea. Same kind of, sort of deal with this. It's giving us a place to start from. It's giving us a square one, so to speak, if you'll excuse the poor choice of cliches. It's giving us a place to start from and to move out from. So if we ever go back to the start, this point will be the start. Anyway, the super fancy name for that is work coordinate system. So there are a few different orientations. What we want to select is z-axis / plane and x-axis. You'll notice that it kind of changes a little bit. So basically, this is changing the way that we are going to set this up. The default one, model orientation, is it tries to use best guess based on the model that we're cutting out on the CNC machine. As you guys will come to learn, if you don't already know, and be unfortunately reminded of multiple times throughout the rest of your life, computers are dumb. Like, super dumb. They're super smart in some ways, but they're also super dumb. And I'm pretty sure I've said that before, so, you know, you've probably heard it from me already. But anyway, computers are dumb. They do a lot of really cool stuff. A lot of that has to do with the fact that humans tell them to do that really cool stuff. Not because computers are particularly adept at doing cool stuff on their own. They just sit there and blink a lot and make grindy noises, and the fans run if you don't tell them to do anything. Well, they don't even make grindy noises, just generally the fans run. So we're not going to leave anything up to chance, and we're going to set that up ourselves. So now we're at this point. You'll notice that if we mouse over the different axes, different parts of them get highlighted. Like if we mouse over the very point on the z-axis, the point gets highlighted. If we mouse over the area a half closer to the dot, then the more of the end part of the base of the arrow gets highlighted. We're going to click on the base of the x-axis. What that's going to allow us to do is it's going to allow us to reorient the x-axis to something on the model. what you want to do is we want it to be oriented this way, and that's diagonal. So it's like lined up with this side right here. Wow, that was a terrible circle. Like this side right here. Like imagine the way that this is pointed. That's the way we want our x-axis to be oriented. So the easiest way to do that is just to click on a line that follows that direction. So I'm going to click right there. And it's not going to work. Why is it not going to work? Normally it reorients itself auto-magically. But of course, it's just going to be difficult. Z-axis. I want the Z-axis to be up. I believe we want the Z-axis to be up. Let me double check that. Okay, yes. We do want the z-axis to be up. So, again, the easiest way to do that is just to click on the inside part of the Z arrow and then click a vertically oriented edge on the model, and then it will point upwards. Now you'll also notice that if we click on the end of the arrow, whatever axis we clicked on will just flip itself. So like now X is facing the other direction. Y is also, but that's just due to the weird way that Fusion 360 rotates stuff. We can do that for Z as well. Z flips around, blah, blah, blah. Well, we want this kind of orientation, though. We want Y pointing, let's choose pen color. We want Y pointing this direction. We want Z pointing this direction. And we want X pointing this direction. So that's the orientation we want. With that done, one final thing to do. If you mouse over the point where all three axes meet, you'll notice that there is a circle there. Click on that circle, and then click on, in this corner closest to me right here, as you can see, this top circle. You'll notice that there are three stacked on top of one another. You want to click on the top one, and it's going to bring it over here. With that done, you've got your axis set up. Cool. Now we got a few more things we got to do. Let's erase all drawings. Under stock, we've got a few different modes. Fixed size box, relative size box, fixed size cylinder, relative size cylinder, fixed and relative size tubes, and from solid. Fixed and relative, basically the only difference is in fixed, you set the dimensions. In relative, it will try and guess the dimensions based on your model. Box, cylinder, and tube are fairly self-explanatory. You know, if you want to cut from a box or a cylinder or a tube. Excuse me. And then from solid is just from the material that we have. So like if you have, you know, your stock is going to be the same as the solid, you're just going to cut some holes in it and stuff like that, and you can just do from solid. Anyway, what we're going to do is we're going to do fixed size box. So go ahead and select that. And then on these, it's going to be 96 inches by 48 inches by ply. So this is going to be ply. It's going to be 0.725. But again, notice how we had to enter that in manually. It's actually a little bit, no, it's ply. It's ply, exactly. But anyway, that's the stock that we're cutting the material out of, or cutting the bookshelf out of. Now, under model position, we're going to offset this from the bottom, minus Z. Shouldn't really change much. As you can see, it looks exactly the same from the side, because that's all it means, is the model position. Do we want to place it at the top of the stock, so it's, in case there's extra stock, it'll be at the bottom? Do we want to center it so that there's going to be extra stock at the top and the bottom? Or do we want to put it at the bottom so there's going to be extra stock at the top? We want it so that there's going to be extra stock at the top, but there shouldn't really be any. We're just doing this just to be safe. Now, with all of that wizardry done, we can hit OK. And now we have something over here labeled Setup 1. Look at that. Look at that aptly labeled setup. So, like with anything else, you can double-click on this and give it a more helpful name. Generally, we'd want to give it the name of what we're making, the machine we're using, just some helpful stuff like that. We're going to keep the Setup 1, though, because we ain't got time for that. So far so good, right? We've got our setup. We've got the setup, well, set up. And at this point, we're ready to get started on basically telling the computer how to cut out all of this stuff. So first things first, we're going to go up here to 2D. You'll notice that we've got a few different options. We've got 2D, we've got 3D, and then there are a few options in there. 3D is if we were going to basically sort of cut rounded edges and things like that and create a more complex design. 2D is just if we're cutting holes and cutting stuff out of other stuff, like, the way you use scissors. 3D is like using, I don't know, a chisel, a hammer and chisel, and cutting out a marble, whereas 2D is like cutting with scissors. To fly directly in the face of my analogy I just made, though, we're going to use 2D Pocket, and we're going to use it to cut out the holes, including these holes over here. So, the way this is going to work is really simple. Well, mostly simple. First things first, we're going to select a tool because we have to tell it what kind of bit it's going to be using when it's cutting. So we'll just click select, and it will think, and it will bring up this whole big intimidating menu filled with just like a bazillion different things, like 100 bojillion different things. We're going to be using inches, so make sure you stay on that one. Don't go down into like the millimeters one, or millimeter ones, or don't worry about this other stuff. We're going to be using inches. And in fact, we're going to be using, is it not here? We should be using a 3/8. Ah, here it is, 3/8. So if you click on one, you'll notice that, hey, you get like a little kind of preview of the tool and a whole bunch of information about it, like, oh, it's made out of carbide, and it's a generic mill tool grade, and cutting diameter is 0.375, and the body length is 0.625. Hey, does that look familiar, by the way, 0.375? I feel like we'll put that somewhere, maybe in our user presets. Anyway, it doesn't matter a whole lot which 3/8 we pick, because we generally just want to, this is meant to represent the tool that we're going to use. As long as it's relatively close to the actual real-life tool you're going to use and the tolerances are okay, you should be all right. It's good practice to select one that at least looks like the tool you're going to be using and has the same dimensions. But if it doesn't, as long as it's close, really and truly. So with that in mind, I'm going to select this 3/8 that looks kind of like this. It's got like maybe a third of it is this light gray color, which represents the actual cutting part, and then the dark gray sort of represents the overall length of the tool and everything like that. We're going to hit OK. So now we got number 1, diameter 3/8 inches flat. That's what that circle with the line through it means also. That means diameter. Now we can go over into geometry, and we can select the, it says pocket selections. This basically means the areas that we're going to be cutting out, because we're going to be creating pockets by cutting them. Hey, grab some more. Never mind. I was about to say something that was going to be too much information. Okay. So now under pocket selections, what you can do is you'll notice that if I mouse over, we're going to be using these blind tab slots here, by the way. If I mouse over this like kind of area right here, I get like the little dog bone outline, and it's in line with the bottom of the blind tab slot. I'm going to select that. Something weird happened, by the way. Everything went blue. When you click on these, everything shouldn't go blue. Really, just the inside should go blue. But that's because computers, being computers, are trying to make an assumption about which side you want to cut. And they're thinking, hey, everything on the outside of this contour right here needs to get cut out. Which means that if we were to, actually say, hey, this is good enough, and then go CNC it, all the blue area would get cut, which is bad. Notice that everything has a bluish tint. We don't want all that stuff cut. Easily fixable though. Just click this arrow and it should flip around, and you'll notice that this area right here is now blue. Easy peasy. So go ahead and select this one too. Make sure that it's facing inwards. And this one, and that one, see, that one defaulted correctly. It was a 50-50 chance to guess correctly, and it did. So cool, we're going to stick with that one. That's really all it comes down to. It's just computer is guessing, and there's a 50% chance that it's going to guess correctly. And it guessed poorly that time. It chose poorly. Gold star if you get that reference. Okay. So that selects that. For some reason we have 7. Can I not math? What is our 7th one? There should only be 6. Probably counting something that I can't quite figure out. Anyway, with those 7 selected, we have selected all the areas that we need to pocket cut. So we can leave heights alone. Don't worry about heights. That's fine. A bunch of more complex stuff pops up. Don't sweat it. It should already default to the correct thing. I say should. The computer is actually pretty good about that. So don't sweat that one too much. And my computer is thinking about life right now. Okay. And it just crashed. Fusion 360 just crashed.
Caution.
Yeah, I don't want to send an error report. All right. Cool. Let's go ahead and open it up again. Ladies and gentlemen, Fusion 360. Let's see how much progress we lost. Hooray! Maybe not much. Open. And then we click the close button. Okay. All right, so it got as far as saving the fact that we wanted it in inches, but it did not save the model. All right, well, let's go ahead and recreate the model. Hey, everybody, review. Select the z-axis plane and x-axis, and then for x, we're going to select that one, and for z, we're going to select this one, and then flip, and then bring it over here. And stock, we're going to have a fixed size box, and it's going to be 96 by 48 by 0.725. And I know this is terribly exciting to hear me just sort of rattle this off. Offset from bottom, OK, 2D pocket. Select our 3/8 inch tool. Hopefully it saved that as a tool we used. No, it didn't. OK, so we're going to have to find that manually again. There we go, not too bad. Geometry. Select all of our pockets once more. I know this is incredibly exciting to watch. And disappearing geometry, you might notice that there's only 6 changes selected now, like there should have been. I must have misclicked and selected something accidentally. It's a good thing that it crashed. It was actually crashing to have my back. Anyway, back to passes. Now, a lot of this stuff starts getting into incredibly specific instances, like stuff that you'll need to tailor to your own machine that you're using to cut things out with. And that's just how it am. To speak with incredibly bad grammar. We are going to set up some stuff, some basic options and things like that for our own use, to sort of simulate the fact that we're going to be using a specific machine and a specific setup. But like I said, take all this with a grain of salt. You don't have to be taking notes on like exactly what value we use for smoothing deviation or anything like that, or maximum step over, because again, that's going to be tailored to whatever machine, and generally the default values are going to be fine. With that said, first thing, sideways compensation. Wow, sideways compensation. Basically, this determines basically it references what direction the bit is going to be spinning on the CNC machine. Really and truly. Some of them are going to be spinning clockwise. Some of them are going to be spinning counterclockwise. Well, really, they're both going to be spinning the same way, but it's the direction in which they move. So you think of like a buzz saw, right? How does a buzz saw spin? Do the like let's do it like this. That's not the thing I wanted to open. Okay, so you've got the teeth of a buzz saw, right? And I swear to God, this is not Sonic the Hedgehog. So the teeth of a buzzsaw spin this way, or they spin this way. A or B. Generally. Tough crowd. All right. Well, generally it's B. That way the teeth can bite into the material, nom nom nom, and just sort of like, blow it away. This way, I always thought for the longest time when I was younger, I always thought that A was the correct one. Because it kind of looks like it should be. Like you got these nasty blades, it's like swords cutting into something, or I don't know, whatever. But it's not. It's actually B. Now the reason why I went on that weird tangent is it's kind of a similar idea here with the milling, except it depends on which direction it moves. Anyway, so with something like climb milling, the cutter, in this case, sort of like the weird. Let's just bring up a picture of a cutter rather than having you suffer my horrible, horrible drawings. Hey, actually, this is a pretty decent representation. Okay, so you'll notice that the cutter rotates the same direction each time, and then so these teeth sort of cut away at it. Now, the difference between conventional milling and climb milling is, in climb milling, the cutter is basically moving this way relative to the material. And, well, they're both actually moving this way. But in this case, the material is being flung up and outwards. And in this case, the material is being mashed down and then flung out this way. It's a better way of explaining it. Again, I apologize for not being on point today. So it's a matter of flinging the material out, or like an upwards, or flinging the material down and then outwards. What we're going to use conventional milling. So we're going to use this example right here where it flings it upwards. It tends to be, well, it can really depend on the tool, but for this kind of material, it's going to be easier on the cutter. It's going to be a little bit faster. It's going to be easier on the material. Everyone's going to be happy. So, you know, we're going to work with that. This one, you know, you can crack the material coming down in. It's generally for harder stuff. So that's where we're going to sit with that. Multiple depths. We can tell it to basically approach it several times. Because normally, if we don't tell it to do anything, it's just going to go like straight down, and then cut through and go, and then come back up and then move on to the next thing. With multiple depths, what we can do is we can tell it to come down a little bit, go through one pass, back up, and then back over, and back down a little bit further, and then over, and then up, and so on and so forth. So we wanted to go multiple depths, and we're going to do it about, in this case, it's going to be about half the diameter of the cutter. So our diameter was 0.375. So our maximum roughing step down is going to be 0.1875. And then we're going to order it by depth, which basically just makes sure it starts at the top and moves its way down instead of doing some sort of weird wonky thing where it comes down a little bit and then it goes down a bunch and then it comes down a little bit less than it did the second time but more than the first time. We're not going to even mess with that. And then I'm doing this from memory right now, so I'm trying to see if there's anything else we need to do before we... Yes. Under linking, there is a ramp option. Now, ramp basically determines how the material, or how the cutter is going to enter into the material in order to do a cut. So you've got a whole bunch of different options, basically starting from the outside, going down in a nice spiral, whatever. That is largely dependent upon the hardness of your material, how fast you're spinning the drill, all kinds of stuff like that. We're going to be using a fairly soft material. We're going to be using a fairly competent cutter, I imagine. So plunge is going to be the option for us, where basically it just goes straight down to the depth it needs to go into, cuts the material, and then moves on. So the plunge in conjunction with the multiple depths means that it's going to plunge down, cuts, come back up, plunge down again, cut, come back up for each depth, rather than trying to drill a hole and then kind of like wiggle until the hole is larger and sort of make a shape that way. We're not even going to worry about that. Plunge and conventional milling and multiple depths, with the step down being half of the diameter. That's really the things that we're concerned about right now. Now it's 7:56. With that done, hit OK. It's 7:56. So I just want to show you one more point. You'll notice now that we've got this whole deal going on with we've got this thing here, and we got a bunch of lines. Well, the thing is actually a 3D representation of the cutter. The lines represent the tool path it's going to take. Basically the way it's going to cut all the stuff out. So just a neato little thing, we can go up here to simulate, click on that, and oops, keep that open, and we can hit the play button here, and it'll actually run along and show you exactly what the cutter would do if it were running on a CNC machine. Of course, the simulation is sans real-life CNC machine, so the tool wouldn't just be floating in midair like this, as I'm sure you all already know. CNC machines work on technology, not quite magic yet. It seems to be taking an incredibly strange path, but that's okay. It looks like it's getting its work done. So as the cuts get more complex, you can actually spend some time running this through the simulation just to see if you're going to get any sort of weirdnesses with the cutting. Like the tool is going to intersect with the stock or something like that at a place you don't want it to. Or it's going to get stuck in another thing because it's going to run into it. Whatever the case may be, we will run into that as we create more cuts to use. Anyway, it's 7:58. I'm going to go ahead and ask the poll questions. And then once that's done, we'll leave it open for question and answer like we always do. I know you probably have tons of questions, considering I sort of stumbled my way through this. But yeah, we'll do that. And then if you don't have any questions after the poll questions are done, you're more than welcome to head out. Have a wonderful weekend. This video and the last video will be up on YouTube tonight. And I will make sure to send you the link, Micaiah, as well as the PDF of everything we've done so far. So, without any further ado, poll questions incoming.